Sorry about that. I think I got cut off due to time constraints, but just kind of trying to rush through this problem here. My leg theorem says that, so for when I'm looking for z, originally it's a leg. When I'm looking for y, it's originally a leg. My leg theorem says that, well, the geometric mean between the whole hypotenuse, so 25 and 20, should equal z, and the geometric mean between 25 and 5 should equal y. And so we have these three variables that we can solve for using the altitude theorem and the leg theorem. The altitude theorem says the geometric mean between 20 and 5 should equal the altitude's length. The leg theorem says that the geometric mean between 25 and 20 should equal z, and 25 and 5, y. Now, to simplify these square roots, I could multiply these numbers and get really big outcomes, or I could just simplify from what I already have. So as far as z is concerned, I could take the square root of whatever big number that is, but I know whatever number that is just going to give me a factor tree of 25 and 20, or 5 times 5, 4 times 5, 2 times 2. So when I simplify this root, whatever it's going to be, I'm just going to cut straight to the chase here. There's a 5 on the outside, and a 2 on the outside, and a root 5 on the inside. I'm going to say that z must equal 10 root 5. Y, same idea. I'm not going to take 25 times 5. It's 125, but when I do 125, the first two numbers are just going to be 25 and 5 anyway. No need to do the extra math. So I know that would be 5 root 5. So y in this case would be 5 root 5. Okay. So 10 root 5 and y would equal 5 root 5. Okay. There's two more examples here that I'd like to do. Get them recorded here. This one's a little different, and you might actually have to set up some ratios here for this, or you might have to do some problem solving. However you want to do it's fine. What I know first is that I can find z using the altitude theorem. So I know z will equal the square root of 8 times 25. Okay. 8 and 25, the altitude, it's a 90-degree angle. I know for sure that I started with a 90-degree angle. I made that altitude. The geometric mean of 8 and 25 is the length of z. So again, I could change that to 200, but why waste the time? And so I know that z equals 10 root 2. Okay, so we know z is 10 root 2. Now, in order to do this next part, I need to know what the hypotenuse of the original triangle is. So I'm just going to add the lengths 8 and 25 together to get 33. I know that the geometric mean between 33 and 25 should equal the length of y, thanks to the leg theorem. So I'm going to say y must equal the square root of 33 times 25. I know that the x should equal the geometric mean of 33 and 8. Well, like I said, there's no need to find what this huge number is just to factor tree it down again. It's completely unnecessary, so I'm just going to use the numbers that are already there. Whatever number that was, those would be my two factors anyway. So I have y equals 5 root 33. And finally, I would have, like I said again, no need to get that big number. It's not necessary. X in this case would equal 2 root 33 times 2, which is 66. Okay? So we're using the altitude theorem and the leg theorem. And finally, another similar figure here. So for this time, we have an unknown right there. So we may have to actually set up the proportions instead of just using the geometric mean. Let's take a look here. We already know what 12 is. It's the length of the altitude. So in previous days, what we could do is we probably just do Pythagorean theorem, say 9, 12, this must be 15 because it's a 3, 4, 5 rectangle, or sorry, triangle. So I could do it that way, or that's not near as fun. I could find x first before I do anything, and then try to find z using my altitude and my leg theorems. Well, I know that the geometric mean between x and 9 should equal 12. So I know that 12 should equal the square root of 9x, or really 12 equals 3 root x. And I can solve for x, and I hope I'm not leaving out too much information. I'm sure that you guys have done this before. X must equal 16. I know you solved square root function equations before. You square them to get them by themselves, and square root of 9 is 3. That's why I pulled the 3 out. So I know you guys know how to do those. Done them in the past. So in this case, x would equal 16. Okay, so there's the first part. Since there's no units, I'm not going to put units, even though we know we're talking about distance. Through Pythagorean theorem 3, 4, 5 triangle, I know this is 3, 4, 5 relationship here. This would have to be 15. I can just cut right to it. But that would be no fun, and we wouldn't use our leg theorem. So now I know that the entire length is 25. Geometric mean between 25 and 9 should equal z. So I know that z equals the square root of 25 times 9. Now I can make that huge number out there, or I could just factor what I have already in here. Z must equal 5 times 3, which is 15. So I knew either way, 3, 4, 5, or through my leg theorem that it must work. It must be the same. Same way here. Looks like I have a 3, 4, 5. This is going to be 20 using 3, 4, 5 similarity. We don't get to do that though. We need to use the leg theorem and get better at that. That's the skill I'm testing and checking to see if you know how to do. Now the geometric mean between 25 and 16 should equal y. And as you can see, I do get 20. There's a 5 and a 5, a 4 and a 4. Sorry, I really should follow the rules the right way. 2, 2. So a 2, there's 4, and a 5 is 20. Y equals 20. Okay. So some of these you can sneak by with Pythagorean theorem, but I really do. I want you to practice. This little fella right here is good to know how to do. Okay. We start adding more abstractions and more variables and things like that. So 3, 4, 5, Pythagorean theorem, things like that, things that you already know how to do. Okay. You can always double check your work using those types of things that we already know. All right. So that's it for today.